Hello friends, today I am going to use this geometrical instrument called Geo Board and a few rubber bands to explain some important concepts and theorems on topic circles for class 9 mathematics. As you can see, I have used this rubber band in a circular fashion to cover an entire circle. Now I use another rubber band to ensure that I make a semicircle. Now I can extend this rubber band to any point on the circumference of the circle to ensure that this makes an angle in the semicircle. As you can see, these 2 points being the end points of a diameter, they are making an angle of 90 degrees in a semicircle. This tells me the fact that angles in a semicircle is 90. To explain the concept further, I can change the direction of the rubber band to make another angle in the same semicircle, and you can see this also turns out to be 90. If I extend the rubber band now here to the other direction, this also is 90. I can use another rubber band and see that another angle in the same semicircle in the same direction also makes an angle 90, thus verifying the fact that angle in a semicircle is 90. I can very well use this concept here in the other part of the semicircle. Angle in a semicircle is 90. Now I'm going to use another concept of chords. As you can see, this diameter is already present and I extend this rubber band to form a chord of a circle. Now children, what I can do is I have to use another rubber band so that I get a line, a kind of a line intersecting the chord at a point. This line looks perpendicular to the chord. Yes, I find that this is nothing but perpendicular from the center to this chord. Now I will verify whether this perpendicular from the center bisects the chord. How to find whether the chord is bisected? I pull up the rubber band from one corner, put my finger here and try to overlap the other part. I find that these two parts overlap each other perfectly, hence verifying that perpendicular from the center is bisecting this chord. I can also see this chord is at a distance of 2 points from the center. I will use another rubber band to have another chord of the same measure, that is at the same distance of 2 points from the center in the opposite direction. I find that these chords are equal in length. What I will do now is use the concept of another rubber band's extension and prove the fact that equal chords are equidistant from the center. You can very well use the method of estimation to see that this distance, that is the distance of one point of the center from one chord to the other, is the same. Now I will tell you how to find angles of a cyclic quadrilateral. I can very well extend this rubber band to another point in the center on the circle and make a cyclic quadrilateral. Can you see the boundary of the cyclic quadrilateral? Now let us use this concept of a diagonal. If I have a diagonal like this, this forms angle in a semicircle. Can you see this forms the diameter, and hence I have you can see this angle is 90, as we just did. Angle in a semicircle is 90. Similarly, look at this diameter. This diagonal is nothing but the diameter, and angle in the semicircle is 90 again. This makes the sum of angles of opposite angles of a cyclic quadrilateral as supplementary. I can make another diameter as the diagonal of the cyclic quadrilateral, and we see that this sum is also 180, that is 90, 90, 180. This reiterates the fact that sum of opposite angles of a cyclic quadrilateral is supplementary. So friends, it was very simple for us to use the concept of geoboards and use simple equipment like rubber band to understand important concepts of circles. Thank you and have a nice day.